So in this first, as you may know, the Baltic Sea is an almost enclosed sea, and it constitutes the only access to the ocean for several European countries. And in the past decades, this water body has been under growing pressure due to the increase of marine traffic, nutrient inputs from human activities, and global warming. So in this context, the operational, precise, and reliable Copernicus Marine Service data helps a lot for the Baltic Sea and constitute a great asset to analyze and forecast the conditions of this economically and environmentally pivotal area. So one way to get familiar with this data is to use GIS software, which aims to provide a visualization and some options to deal with this data. And in this example, I'm going to show you how to use this data with a plugin developed by Noveltis, and to easily display NetCDF variable from the Copernicus Marine Service. So first of all, we are going to load a background to our project in QGIS. So here you can see my new project in QGIS, and you can select layer and add a layer. Here we are just going to connect to a WMS server, which is named Map Server Demo. You can find all the informations to connect to this data and this server on the user manual, which is provided on the platform of the Copernicus Marine Service. Connect to this server, and here you have several layers which provide backgrounds or continent bounds, for example, in QGIS. We are going to use the Blue Marble map, which is a good background for our projects. You can click on Add, and now close this data. So you can see that you have the map of the world now. We are going to zoom on the Baltic Sea and proceed to our treatments on some Copernicus Marine Service data. First of all, we are going to open the NetCDF to GIS plugin here with the Copernicus Marine Service logo, and it's here. Here you can import NetCDF data, and first of all, we are going to use data of biogeochemical model on the Baltic Sea with a spatial resolution of 2 kilometers and on a daily mean basis from the 20th of June to the 4th of July. So this is this file. You can click on Open to load it into the NetCDF to GIS plugin, sorry. And here you have your file. You have access, thanks to the plugin, to several informations. First of all, you have access to all the variables available in this NetCDF file here, with nitrate, oxygen, and chlorophyll, for example. You have also access to metadata with the resolution of these products and some information on the grids and the conventions of this product. And now we are going to display the chlorophyll concentration in the Baltic Sea for the date from the 20th of June to the 4th of July. To do so, you have two options in this plugin. So select the right variable, right click on it, and here you can select or add layers function to add individual layers corresponding to several time frames. Or you can select the sequence layers option, which is going to make short animations with every time frame layer scrolling one after the other. So we are going to use this sequence layers option. Click on it. And here you can select all the time frames of your NetCDF data from the Copernicus Marine Service. So press the first time frame, press the shift key on your keyboard and select the last time frame. And here you can just select the min and max for all layers option for the values of each layer. Once it is done, you can click on Start to start the animation. If you go to the main QGIS project, you can see that the different layers are scrolling one after the other, and you can see the maximums of chlorophyll here in the Gulf of Riga, for example, at the beginning of the month of July. Once it is done, you can just go back to the plugin and the control window and stop the animation and close this window. Now we have all the layers loaded on our QGIS projects, and we can just change their representation and narrow the value range to have more relevant palettes. To do so, for example, we can just activate the first layer here, right-click on it, and access to the properties of the layer. Here in the symbology panel, you have access to the representation of the color bar, the values minimum and maximum of your layer. So here we are going to change these values from 0 to 20 milligrams per cubic meters, and just check that the color ramp is spectral, but we are going to invert it to have minimum values in blue and maximum values in red. Once it is done, you can just click on apply here and OK. So you can see that this first layer has maximum chlorophyll concentration here and here along the coasts. Now we are going to see, we want to see the same palette on other chlorophyll concentration layers. That's why we are going to apply this style here to the other layers. So if we select the first layer, right-click on it, go to Style, copy the style, and now we can apply it to the other layers. Select all the other layers of chlorophyll by pressing Shift on your keyboard. Right-click on it, and you can select Paste Style. Now we can just activate all the layers and compare how the chlorophyll concentration evolves a long time. For example, here on the 20th, 21st, and if we skip some layers, we can see that there is a chlorophyll bloom at the beginning of July in the Gulf of Riga here. So we have seen how to import chlorophyll concentration data on our project. And now we are going to use a shapefile from the EBONDET portal, which is a Polygon file defining a region. In this case, it's a shapefile from the EMODNet portal, which give access to several marine regions, and we have selected the Estonian exclusive economic zone region. To import this layer, you can just go to layer, add layer, and a shapefile is a vector layer. So add vector layer here. Here we are going to browse and look for our data. So you are going to the directory where you have your data. And here, the economic zone the exclusive economic zone of Estonia is the EEZ point shapefile here, and you can open it. All the links to these materials are explained on the user manual on the Copernicus Marine platform. Once you have found your shapefile, just open it. And here, you can click on Add and Close. So if you take this layer on top of all the other layers and zoom on your project, you can see that the Estonian exclusive economic zone is just over Estonian coasts here. And what we want to do is to extract the chlorophyll concentration on this polygon. To do so, we are going to select a function which is Raster Extraction. And here we are going to select Clip Raster by Mask Layer to extract the raster values of chlorophyll onto our EEZ polygon. Here we can select our input layer, so the raster we want to extract on our polygon. So we are going to select the 1st of July layer. Here it is. And we are going to select the mask layer, so the EEZ polygon here. Now we can just click on Run and close this window. As you can see, a new layer clipped results, and this layer is in levels of gray, so we can just change the representation of this new extracted layer. To do so, we are going to copy the style of the preceding layers of chlorophyll. So you can just select Open Style, Copy Style, and here, right-click on it and select Style, Paste Style. If we deactivate the first layers over all the Baltic Sea here, we can see that only the chlorophyll concentrations on the 1st of July on the economic zone of Estonia are remaining on our project. So that's a good way to extract informations from the Copernicus Marine service onto a polygon, a shapefile polygon. Here, you can just rename this layer. Right-click on it, select Rename Layer, and here we are going to rename it Chlorophyll Ale on the 1st of July 2021 EEZ extract. So now you have seen how to extract some values on a precise polygon. In the second part of this training, we are heading back to the NetCDF QGIS plugin, and we are now going to focus on how to represent current vectors in the Baltic Sea region. So if you take the NetCDF QGIS plugin here, we are going to import data of currents. So from the analysis and forecast physical model over the Baltic Sea on the Copernicus Marine Service with 2 kilometers spatial resolution on a daily mean. And we are going to select currents on the 2nd of January 2019, which correspond to an episode of blizzards on the Baltic Sea. And so we are going to represent and see the currents modeled by the Copernicus Marine Service. Here you can select this layer and click on Open. So if you focus on the analysis forecast UNV data here, you have access to eastward seawater velocity, U0, and northward seawater velocity. So before displaying any current field, we need to load each component of this current field. To do so, we are going to select the U0 layer, is the U0 variable, sorry. Right-click on it and select Add Layers. You select the only time frame on the data, which corresponds to the 2nd of January 2019, and click on Add and Close. You can see that the new layer had been added to your QGIS project. We are going to do the same for the V0 variable, northward velocity. Right-click on it, Add Layers, and Add and Close. Now you can reduce the QGIS plugin and see that each scalar field have been added to your project. Eastward velocity here and northward velocity here. So what we need now is to compute the current vector. So go back to the plugin, and here on the layers panel, you have access to U0 and V0 layers here. Now we are going to combine these two layers to compute the current vector field. To do so, select the first one, press Ctrl on your keyboard, select the second component of your vector field. Now you can right-click on these two layers and select the vectorize function here. Here you have to select some options. So we are going to select the U0 component as east-west velocity, the V0 component as north-south velocity, and we are going to use the norm of currents to have direction in the good direction. We are going to apply a downsampling factor of 10, which correspond to a reduction of the representation of the arrows of the vector field in order to have a readable display. You can just select an output directory and type the name of your vector field. So here we are going to type the date and the current name. Once it is done, you can click on vectorize, and QGIS is going to compute the vector field for currents in the 2nd of January 2019. If you close this window and reduce the NetCDF to GIS window, you can see that here you have the vector field represented on the Baltic Sea. What you can do is just uncheck the U0 and V0 scalar fields here to only have arrows over the Baltic Sea. Now we are going to change the presentation of this vector field and the values here. And we are going to import an existing style already done to this QGIS project. To do so, select your layer, right-click on it, and go to Properties. Now you can just click on Style here at the bottom of the window and load an existing style. Browse to your directory, and here you should find, it's also shared on the Copernicus Marine platform. Here, the current scale.qml file, which is a style file already done by Noveltis. Click on Open, Load Style, and here you can see that you have different values for each category of vector. You can click on apply and OK. If we go back to our QGIS project, we can see that we have strong vectors heading south here on the coast of Finland, corresponding to the blizzard episode in January 2019. So here, if we deactivate the chlorophyll layer and the polygon layer, we have a vector field all over the Baltic Sea during the blizzard episode in January 2019. It is possible to export this layer, this vector layer, by right-clicking on it and select here, export and save feature as. So you can import it on several in several formats. In GeoJSON, it can be useful for additional processing by Python or other softwares. So you just have to select the format, choose a file names as vector field, for example, save, and now you just have to click on OK. And now each vector have been saved to a GeoJSON on this new layer. So once it is done, we can move to the last part of this beginner training, which is named sea ice conditions in the Baltic Sea. So in this last part, we are going to focus on how to display the sea ice concentration data using a regional forecast over the Baltic Sea. So you can just uncheck the vector group here, and we are going to use again the NetCDF QGIS plugin, which enables to easily load NetCDF files from the Copernicus Marine Service. So first of all, we are going to click on plus here and use the sea ice file here, which correspond to physical model analysis and forecast on the Baltic Sea with the same resolution of 2 kilometers. And we are going to observe the forecast of sea ice between the 1st of March and the 7th of March in 2022. Click on open. And now you have access to the sea ice concentration variable, the sea ice thickness variable here. And again, all the metadata with the resolutions, the region we have downloaded in longitude and latitudes, and other additional informations about the Copernicus Marine Service and this product. If we go back to the sea ice conditions, we are going to use the sea ice concentration on the Baltic Sea between the 1st and the 7th of March 2022. Here you can, first of all, right-click on the sea ice concentration layer and select Add Layers. Here you have access to all the time frames. You can select them all by using the Shift key on your keyboard, but you can also select only some of these layers, every other layer, for example, by clicking with Control on your keyboard. Now we are going to import this data to our QGIS project. So you can just select Add and Close here. You can reduce the NetCDF QGIS plugin here. And you can see that you have the evolution of the sea ice concentration forecasts for the 1st, 3rd, 5th, and 7th of March 2022. Here we can just double click on the layer to open the properties and ensure that the minimum value is on 0 and the maximum value of sea ice concentration is on 1, and just invert the color ramp from blue to red again. Click on apply to apply it to the first layer, and now we are going to copy and paste this style to other layers. Right click on the first layer, go to style, copy style, and apply it to the following layers. Right click on it and paste style. So here, if we compare the 1st and the 7th of March forecasts of sea ice, we clearly see the evolution of the sea ice. Again, it's possible to export these layers, for example, and right-click on the first layer, export, save as, and here you can save this raster layer as a GeoTIFF, for example. You just have to select a file name, for example, tests, and just save the extent of this layer, and OK. It is also possible to convert this layer to a vector layer, so to polygons, for example, using Raster Conversion and Polygonize here. Here you can select the input layer, so your sea ice concentration layer, give a new field, for example, sea ice concentration for the resulting polygon layer, and click on Run. So now your layer is a whole polygon. You can deactivate this. You can also apply some computation on this raster layer using the Raster Calculator. So to do so, you can just open the raster menu and select Raster Calculator and apply some computation on the sea ice concentration layer here. For example, as the sea ice extent is defined by a sea ice concentration higher than 15%, we can just apply, for example, a filter on this raster layer and only keep sea ice concentrations higher than 15% to generate a sea ice extent layer. So here we have selected our sea ice concentration layer, and we are going to select on the computational window the 0.15 threshold. Here you just have to select an output name. So here we are going to select sea ice extent. Click on Save on a GeoTIFF format. And now you can click on OK. So here we have selected values of sea ice concentration higher than 15%. And so the resulting value is a layer with the resulting layer is a raster layer with values of 1 for values of sea ice concentration higher than 15%, and for 0 for sea ice concentration below this threshold of 15%. So here we can now, for example, convert this raster layer to a vector field. So select Raster Conversion and Polygonize. And if we select the sea ice extent layer as input layer and the resulting layer name field as sea ice concentration and click on run, you can see that the new resulting layer is a vector layer in pink here. And we have access to this layer, to the attributes of this layer. So you can right click on it and open the attribute table. And here you have access to the values of each polygon of this layer, with values of 1 for sea ice concentrations higher than 15% or 0 to sea ice concentration below this threshold. The last step I'm going to show you is that you can filter this polygon layer based on the sea ice concentration variable here. So if you double click on it, we are going to apply a filter and only select values equal to 1. Click on OK. And now you have this polygon in pink that corresponds to the sea ice extent, so the sea ice concentration higher than 15% in the Baltic Sea. So what you can do now is just export this polygon as a shapefile, for example. Right-click on the layer, select Export, and Save Feature As. So now you can select the S3 shapefile format here to export this polygon as a shapefile and use this shapefile on other applications with other softwares as you want. Just select the file name and select the sea ice extent shapefile. Click on Save and OK. So here we have seen how to import chlorophyll concentration from the Copernicus Marine Service on QGIS, or to deal with the shapefile polygon to extract some informations and variables. We have seen how to see vector fields using the NetCDF QGIS plugin for the QGIS software. And on this last step, we have seen how to display sea ice concentration variables, filter them based on a threshold, and to export resulting layers as polygons.